Hello, and welcome back to AI Ed, from bits to breakthroughs. I'm your host, Kelly 1.0, one of the AI-generated avatars here at newbits.ai. Thank you for joining us again in our AI Basics, the Fundamentals series. In our last episode, we explored the key technologies behind AI, including machine learning, neural networks, deep learning, and natural language processing (NLP). Today, we're going to dive into the mechanics of how AI systems are built and trained. Specifically, we'll focus on data, algorithms, and training, the building blocks of modern AI systems. By the end of this episode, you'll have a clear understanding of how AI systems learn and improve, the importance of data in AI, and the role that algorithms play in shaping AI behavior. Let's get started. Let's begin with data, the foundation of any AI system. In simple terms, data is the fuel that powers AI. Without data, AI systems cannot learn or make predictions. AI relies on vast amounts of data to identify patterns, make decisions, and solve problems. The more data an AI system has access to, the better it can learn. However, there's an important balance to consider between the quantity and quality of data. Let's look at quantity. AI systems thrive on large datasets. The more data they can analyze, the better they can recognize patterns and make accurate predictions. For instance, AI systems that analyze text, like chatbots or language translation tools, benefit from having access to millions of examples of human language. Now let's look at quality. While large amounts of data are important, the quality of the data is equally crucial. Poor quality data, such as data with errors, duplicates, or irrelevant information, can lead to inaccurate predictions. High-quality data is clean, accurate, and relevant to the task at hand. A smaller, high-quality dataset often yields better results than a large, poor-quality one. For example, if you're training an AI to recognize objects in images, a small set of clear, well-labeled images is often more useful than a large set of blurry or mislabeled photos. AI systems trained on high-quality data learn faster and make fewer mistakes. This balance between quantity and quality is essential. AI systems need large amounts of high-quality data to perform well, especially in complex tasks like medical diagnostics or self-driving cars. For instance, the more driving data a self-driving car AI processes, the better it will recognize patterns and safely navigate the roads, but only if that data is accurate and representative of real driving conditions. At newbits.ai, we stress the importance of balancing both quantity and quality when working with AI models, tools, and platforms. Next, we have algorithms, the brains of AI. An algorithm is essentially a set of instructions or rules that tells the AI system how to process data and make decisions. In AI, algorithms define the steps the system takes to solve problems, whether it's classifying an image, predicting a stock price, or recommending a product. Let's explore 3 common types of algorithms and see how they're used in the real world. 1. Decision trees. These algorithms make decisions by following a tree-like model of choices and consequences. Each branch represents a decision, and the leaves represent the outcomes. Decision trees are often used in applications like medical diagnostics. For example, imagine a doctor diagnosing a patient's condition based on symptoms. A decision tree might be used to guide the AI through a series of questions. Does the patient have a fever? Are there any rashes? Ultimately leading to a diagnosis. Decision trees help break down complex decisions into manageable steps. 2. Neural networks. As we covered in the previous episode, neural networks simulate the way the human brain processes information. They are used in everything from facial recognition to language translation. For example, when you use facial recognition to unlock your smartphone, a neural network is at work. The network processes the patterns in your face and matches them to the stored model of your face to determine if it's really you. 3. K-nearest neighbors, KNN. This algorithm classifies data by comparing it to the most similar points in the dataset. Essentially, it looks at neighbors to make a decision, classifying new data based on what it has learned from similar examples. It's commonly used in recommendation systems. For example, Amazon might use KNN to recommend products to you. If other customers with similar shopping habits purchased a certain product, the algorithm considers them your neighbors and suggests the same item to you based on their preferences. One key thing to remember about AI algorithms is that they don't perform well on their own. They rely heavily on high-quality data. A good algorithm paired with poor data will lead to bad results, while a well-designed algorithm trained on high-quality data can be extremely powerful. Now, let's talk about the process of training AI systems. Training is how an AI model learns to perform a task. During training, the system is fed data, and the algorithm processes that data to learn patterns or relationships. Over time, the AI improves as it processes more data and adjusts its internal parameters. Earlier in this series, we discussed supervised, unsupervised, and reinforcement learning, the three main types of machine learning that AI uses during training. Let's revisit these concepts in the context of training an AI system. 1. Supervised learning. In this type of training, the AI is trained using labeled data. The system is given a set of input-output pairs, and it learns to map inputs to outputs based on the examples it has been provided. Once trained, it can make predictions on new, unseen data. For example, when you teach a system to recognize handwritten digits, you provide it with thousands of labeled examples of handwritten numbers. The AI learns to associate the input, the image of a digit, with the output, the correct number. 2. Unsupervised learning. In unsupervised learning, the AI is trained on unlabeled data. The goal is to find patterns and relationships within the data without being explicitly told what to look for. For example, AI systems used in customer segmentation group similar customers together based on patterns in their purchasing behaviors, without needing predefined labels for the groups. 3. Reinforcement learning. This type of learning involves training an AI by rewarding it for making the right decisions and penalizing it for wrong ones. The system learns through trial and error. For example, in video games, AI opponents are often trained using reinforcement learning, where the AI learns to beat human players by playing thousands of games and improving its strategy over time. There are three main stages in the training process. 1. Data collection. The first step is gathering and preparing the data. AI systems need vast amounts of data to learn effectively, which could include anything from text and images to video and audio. 2. Training the model. During this phase, the AI system uses algorithms to analyze the data and learn from it. The system goes through the data multiple times, making predictions and adjusting its internal settings to minimize errors. This iterative process helps the AI improve over time. 3. Validation and testing. Once the AI system has been trained, it's important to test it on new data that it hasn't seen before. This helps ensure that the system can make accurate predictions on real-world data, not just the data it was trained on. For instance, consider a self-driving car. The AI system must be trained on vast amounts of road and driving data, like recognizing pedestrians, other cars, traffic lights, and road signs. After training, the car's AI is tested in different environments to make sure it can safely navigate streets in the real world. To summarize, data is the fuel for AI. Without it, AI systems cannot learn or make predictions. The balance between quantity and quality is key. Large datasets are useful, but only if the data is accurate and relevant. Algorithms are the rules that guide AI behavior, processing data, and making decisions based on learned patterns. Training is how AI systems learn and improve, through repetitive exposure to data and continuous adjustment of internal parameters. These three elements, data, algorithms, and training, are the core mechanics behind AI systems. Understanding how these pieces fit together is crucial to grasping the power and potential of AI in fields ranging from healthcare to entertainment. At newbits.ai, we explore a variety of AI models, tools, and platforms that leverage data, algorithms, and training to solve real-world problems. Whether you're curious about AI-powered recommendation systems or the algorithms behind image recognition, our AI Solutions directory has everything you need to explore. In our next episode, we'll be discussing AI in everyday life, practical applications, where we'll explore how AI is transforming industries and reshaping the way we live. Thank you for joining me for this episode of AI Basics, the Fundamentals. And as always, stay curious, keep exploring, and remember, it's all about the bits, especially the new bits.